If you're looking for a content explaining how to observe your OPA Gatekeeper policies, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is part of the Kubernetes series where we covered lots of various topics. If you pay attention, I recently released an episode introducing a series of episodes related to security. In this episode, I explain briefly the various tasks that we need to achieve to secure our Kubernetes cluster from the build to the runtime. In today's episode, we will focus on creating security policies in our cluster, avoiding any human mistakes. In this episode, we will use a CNCF project named OPA Gatekeeper. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start with a small introduction on why we should create security policies in our cluster. We will then introduce to the Open Policy Agent framework that is behind the OPA Gatekeeper project. Then we will cover in details the OPA Gatekeeper, describe it. We will present the Gatekeeper library having pre-built constraints and mutations that we can easily use in our cluster. We will look, of course, at the various observability signals that Gatekeeper will provide to us and how we could take advantage of it to observe the various policies that we have implemented in our cluster. Like explained in the episode on how to secure your Kubernetes cluster, we need to make sure that we assign the right policies in our workload. Usually those policies would be defined in the security context of our deployment, stateful sets, and others. In the security context, we will define which user, which group, the FS group, would be used in our pod or our containers. We can also configure more advanced security concepts like the type of kernel capabilities that we can drop or add into our pod. The ability also to mount root file systems only in read-only mode and more, in fact. A few months ago, before Kubernetes 1.25, we used to have the pod security policies, PSPs, where we could define a global policy per namespaces or service accounts that we are authorizing. PSP was a great way of blocking or just being notified that a given workload are trying to grant higher rights than the one that we are authorizing in our cluster. Since Kubernetes 1.25, this concept has been replaced by pod security standards, but they are mainly focused on the settings related to the security context of our workload. In fact, it was even true with PSP. So when building security policies in our cluster, we clearly want to control the pod security used by our team, but we also want to add extra rules simplifying the management of our cluster, such as making sure our team are putting the right labels or annotations. We can also control that each team are defining requests, and even more, that those values are reasonable. Same for the limits. We can also look at the number of replica defined within an HPA, or that we can look at that each deployment has defined a readiness or health pros in our deployment files. That is the reason why there are several CNCF projects that is currently helping us to control various things in the workload made by our team. There is, of course, Kyverno, very popular, and OPA Gatekeeper. OPA Gatekeeper is a dedicated project for Kubernetes from the OPA Policy Agent project. Before we jump into the concepts of OPA Gatekeeper, you need to have a short explanation on OPA, Open Policy Agent. That is going to be a central component of OPA Gatekeeper. OPA is a smart project that provides a specific language helping us to create our own policies. The approach of OPA is not to ship our policies within our code, but to decouple it. OPA will act as a component helping you to take decisions based on your own policies. The concept is simple. Our component will send an API request with the JSON content to OPA, and OPA it will basically run our policy against this payload and return a decision. The policies in OPA is written in a specific language named Rego. So OPA won't reject or block, but it will help other tools to make decisions based on your own rules, which means OPA is not designed for any specific domains or use case. We could imagine using it to control our resources, the scaling policies, the type of operating system used, the type of repo used within our image, and so on. It means that OPA is not going to be used in a standard mode. It will be used in combination with other tools. But how do we use OPA? So first, you need to deploy it. It could be either installed as a CLI, as a client. Once installed, you will be able to evaluate the payload against a policy defined. But usually, we install OPA in a server mode, which means we launch OPA in a host or a container by loading a specific policy. And then to evaluate a decision, we will simply need to send an API request to OPA, passing the content in the JSON in the payload of the request. So OPA will usually end as a sidecar container or a central gateway to provide an easy to use framework to policy decisions. For example, OPA has created a tutorial with Istio where OPA was injected as a sidecar next to Envoy. In this use case, Envoy will receive a request, and before sending it to our workload, it will first send an API request to the OPA sidecar to get the feedback on what type of decisions it needs to take. So filter the requests, or simply forward the request to our workload. It's going to be in the Rego file that will define our rules, in fact, decisions, meaning that the Rego file will define how OPA will respond to an incoming data. In Rego, for example, we can define one single rule. So here the rule is named rule, and it has 3 statements. So the rule, named in our case rule, would be true if all of those statements are true. If you want to create an OR, then we would need to create 2 instances of our rule. So here you can see that we have a rule with statement 1, and then we have rule statement 2. So here the decision will be based on the results of the statement 1 or the results of statement 2. Rules can have arguments. In theory, it's a bit like a function that we could use in one of our rules. Similar to JavaScript, Rego is a language that is very easy to use to parse our JSON or YAML content. For example, if I want to reach, for example, some details from a manifest files of a pod, and I want to reach the container image, I could say pod.spec.containers 0, for example, for the first container image. This is going to point to the image name of our first container of our pod. Rego has plenty of functions and operations for string, for numbers, for comparing stuff. So there is plenty of things out there. So it also have predefined operations that help us to loop within arrays or content of our payload. For example, we have every, in, and some. So for example, let's say we want to create a rule that checks either the port name or the port number to determine if it's HTTPS. So I will have, of course, 2 rules, HTTPS protocol, the 2 statements, and I will go through the containers of our deployment. So here, some containers in pod spec containers, and then I'm getting the port, the container port. And I do the same thing for the container name. But I won't go too deep in Rego because it would take forever to explain all the potentials of this language. But one important thing with OPA is that you have a testing feature available in the CLI. That means that we could technically create unit tests on our policies and include them in our CI/CD pipelines. But the most important thing is that OPA provides a playground web UI, helping us to build and test our policies. So here is the link to the playground of Rego. One amazing feature provided by OPA agents is observability. OPA by default provides Prometheus metrics. So the metrics produced mainly focus on reporting the health of the Go runtimes and to understand the health of the OPA agents. And it also provides an open telemetry distributed trace. But to take advantage of this, you will have to enable it by configuring the OPA agents configuration file. By adding these sections in the configuration file, so you will have to add the distributed tracing objects, of course determine the protocol, so gRPC, and the address of your hotel collector or the endpoint where you want to send your OpenTelemetry spans in a gRPC format. OPA Gatekeeper is a Kubernetes operator helping us to create specific security policies for our Kubernetes cluster, covering not only security context settings, but any details that could be available within our services, our deployments, any manifests of any Kubernetes objects. Of course, as expected, OPA Gatekeeper will rely on OPA, and of course on Rego to create your policies. The value of OPA Gatekeeper is their library with predefined constraints and mutations, meaning that if you're far from being an expert in Rego, then don't worry, you can also reuse existing libraries created by the OPA community. As expected from an operator, OPA Gatekeeper will provide a control plane, allowing us to define our roles. Those roles would be defined using new CRD provided by the operator. We have constraints templates, and mutations. OPA makes our life easier, where we can build templates with the constraints template CRD that will have, of course, a specific Rego scripts, and we will have a set of parameters that we'll define. So which means it's gonna make our constraints rule completely configurable. For example, if I want to create a constraint on the maximum number of CPU memory requested, I will be able to create a parameter with the max value, meaning that I could use these constraints and customizing depending on the namespace. So the value will change, the max value will change depending on the namespace. But let's first explain the constraints framework available in OPA Gatekeeper. The idea is that we will define a constraints template having a specific name. The name is important because it will be the future type of constraints name that we will use later when deploying our constraints rules. Imagine that this is gonna somehow ends up to be a new CRD in your cluster. This constraints template will have details like the targets, allowing us to define how these targets will interact with our Kubernetes cluster. Targets is a list of targets. For each target, we will define the type of target. It could be either admission Kubernetes gatekeeper.sh or authorization Kubernetes. Usually we use admission Kubernetes because it will target any objects created in our Kubernetes cluster. Authorization is designed for rules evaluating requests sent to our Kubernetes API. Out of the type of objects that are targeted by our constraints, we will of course have a Rego sections where we will add our Rego code defining our role. So here is a template for a Rego rule. The only difference with the traditional Rego scripts from OPA is that the rule needs to be named validations. And you need to retain two properties, the message with the message of the validations and the details giving more reasons on why this object has been denied. The other difference that we have from a traditional OPA scripts is that the Rego Gatekeeper scripts will have only one single package. Once our template is deployed, we can inform Gatekeeper that we want to deploy a constraint using this existing template. For example, I'm creating constraints template controlling how our ingress are configured using SSL. So this constraint will be named Kubernetes HTTPS only. So here is an example of the constraint template. So this template is controlling that our ingress rules has HTTPS configured. To build this constraint, I will need to configure it with the optional parameter defined in this template. And this optional parameter is called TLS optional. That could be set to true. So if I want to deploy these constraints within my cluster, I will simply configure this constraints. And these constraints, I can see the kind is Kubernetes HTTPS only. When deploying constraints, we can even specify what content is targeted by this rule. So with the property match, helping us to define which namespace are targeted by the constraints with the namespace, where we could pass a list of namespaces, or in the opposite, we can say namespace excluded, where here we're passing a list of excluded namespace. Or we can use a namespace selector, or also simply target objects using a label selector. Last, we can also configure how Gatekeeper will react in case of violations. And this is done with the settings enforcement actions that could be equal to deny, dry run, or warning. Deny will reject the objects in the scheduler. Dry run use when using kubectl dry run. And last, warning will simply send a message when we're deploying our objects. The other CRD provided by Gatekeeper is mutation. Mutation has lots of options to either modify the metadata, the image of the container used, change any settings of the manifests, and more. For example, I can modify all the deployments to add the required labels or annotations. Mutation is a great feature, but it could result in breaking the behavior of our workload. So mutation rules on metadata make sense, so we can force to everyone add the standardized annotations and labels. But other things like the security context or the kernel capability, it could bring a challenge and make our workload completely unstable. So I would prefer to block the deployments and force our team to respect the policy that we've defined. What is great with Gatekeeper is the ability to extend our policies by creating our own constraints templates. But moreover, it has predefined sets of library. Gatekeeper has a specific web page listing the existing sets of constraints templates and mutations. So here is the URL. There are lots of existing constraints that we can either use like this or even just customize it. So we can define constraints on the request or limits, controlling a reasonable number of replica on our HPA, making sure that our workload has the right sets of labels or annotations, block any services deployed with a node port, and more. Of course, it also provides constraints related to the pod security defined in our pods to block pods that are not respecting our default sets of capabilities, blocking workload, not having read-only file systems, or high privileged containers. It's meaning that all the basic security policies that we need to create in our cluster, avoiding any workload that has high privileges or high user group or whatever, is already there. So we simply need to utilize the existing libraries. And again, we can adjust those templates to our need, customize the constraints before deploying it by configuring the parameters of the constraints or simply limiting to specific namespaces. The library also provides a set of mutations. For example, if you're looking to force the configuration of a few security contexts on the workload of your team, you can do that. Like I said, mutations are great, but it will need to measure the impact of forcing few workloads to use predefined sets of capabilities, for example. Similar to OPA, Gatekeeper will provide observability. In fact, when you deploy OPA, you will find two different workloads. So the control plane named the control manager and an extra workload named audit. This workload, the audit, will basically produce lots of logs on the various audit triggered by OPA. All the violations related to our constraints that we've deployed will end up in the control manager logs. So we could be able to be aware of any violations that has been denied or simply thrown a warning. Meaning that the logs that are produced by those two workloads will be a valuable source of data that we will ingest in our Observability backend. The awesome thing with this logs is that it provides lots of details in the logs. There's a JSON payload sharing the type of validations or mutations, the source, the name of the constraints, the Kubernetes metadata of the object that have validations. If required, we can extend the logging by enabling log stats on the animation controller pod. This is possible by adding these following arguments when we start the control manager. This results into producing detailed statistics on the duration of each Rego code. It is clearly interesting, but it will produce tons of logs, and it may result of being a bit expensive. I think the existing logs produced by OPA are already producing lots of details and value. So the games would be to use the collector or Flimbit to read the logs from those pods and the cluster, in fact. Use a plugin, so in the collector, the transform processor, to parse the content and add extra metadata to the logs produced by OPA. It could be also interesting to add the Kubernetes attributes of the objects that has evaluations to the log stream. So then the log will be indexed to that specific workload. But keep in mind that if OPA has blocked the deployments of a given pod, then any plugins like the Kubernetes attribute processor will never be able to find the pod because it technically never been scheduled and deployed. So I would recommend to leave all the details of the logs produced by OPA to the OPA Gatekeeper workload. And of course, enriching that log by parsing the extra fields. To achieve this with a collector, we will need few things. We will need the routing connector and the transform processor. So let's have a look at a collector pipeline that I've built. So as you can see in this collector pipeline, we're using the file log receiver to log any logs of the cluster, but we're using specifically the routing connector that will trigger a specific pipelines for the logs produced by OPA Gatekeeper. That pipeline is now named logs audit, and we have another log pipeline for logs default for the other logs. The condition to trigger the pipeline is based simply on the namespace. So here in my case, the namespace is Gatekeeper. The logs audit pipeline will simply parse the content provided by OPA Gatekeeper, that is adding a JSON payload with lots of interesting information, such as the type of events, the type of constraints, and so on. By parsing those fields, we can use those to extract metadata to create statistics on our violation. Out of logs, Gatekeeper will also produce Prometheus metrics, helping us to keep track on the number of constraints, and the number of mutations, the number of requests received by the control plane, the duration of a validation request or a mutation. You also have the number of current validations detected and the times to run an audit. So simply by using those metrics, we could clearly build the precise dashboards following the status of our policies and the health of Gatekeeper. In my case, I have built the following dashboards in Dynatrace that utilize those metrics. And at the bottom of the dashboards, I have a specific section that is relying on logs. So I'm able to do some stats on the validations, the constraints detected by namespaces to figure out if they are teams that are usually not respecting the policy that we defined. That's it for today's episode related to OPA Gatekeeper. As you can see, it has lots of interesting features. I really like the fact that the constraints are fully customizable with the help of the constraints template. And we can also, of course, define which object will be targeted by constraints, playing with the label selector, the namespace selectors, or even just exclude namespacing. Out of that, I think the Rego language is very powerful, allowing us to build a lot of precise rules, but it could be very difficult to start onboarding, building precise and robust scripts using Rego libraries. So that's why I think it's very exciting to see that OPA Gatekeeper provides these sets of library with predefined constraints. So then our onboarding journey is much more simpler and smoother. We don't have to reinvent the wheel, we just reuse the existing libraries. On the top of that, I think from the observability angle, OPA provides the right sets of metrics that are interesting, but I think from the log perspective, there's lots of details that could help us to react, automate things, reach out to the team that is making those validations. So I think it's relying on metrics, but also on logs will provide an extended way of understanding the current usage of our policies within our cluster. Similar to OPA Gatekeeper, I mentioned there is Kubernetes, so I will also look at Kubernetes to see if there are any differences, anyway, if it's one project is simpler to the other. So keep posted, I will try to produce that content soon. If you enjoyed today's content, don't forget to like, and subscribe to the channel. So see you soon for another episode.